orbital theory. The only thing you need to understand is degeneracies. Okay, I'm writing it again, degeneracies. Here degeneracies is a simple word which means that you have two possibilities of levels, energy levels, same energy levels. The next thing when we are going to discuss about crystal field theory and ligand field theory is ligands or coordination complexes. I used that word, and that word of course looked like rocket science, but no, it's not rocket science. It's just another name, friends, for molecules with transition metals. Yes, simple. So here we have another word, that is ligands. Okay, so let's see the postulates of crystal field theory and how it is formed. The postulates are simple. The crystal field theory describes about the breaking of degeneracies. These different states get broken down due to the you can say electric fields or electrons of the ligands. Let's understand what's ligands. Okay, here we have in the next paragraph ligands. Ligands are nothing but the ions which are connected to the central atom. For example, let me draw a simple diagram here. Okay, a simple diagram. Let's say this is P, uh, let's say this is O, let's say this is O, H. I'm just giving you a small, you can say imaginary diagram here. Okay, what are ligands? If this is the central atom, then these are ligands. Why? Because they're connected to the central atom. The ions which are connected to the central atom are called ligands. Due to the interaction between the central atom transition metal and the ligands, there is an attraction between the positively charged metal cation and the negatively charged non-bonding electrons of the ligands. There are some non-bonding electrons here. Due to this you can say interaction, we have some kind of attraction forces going on. Okay, this theory is developed. How it is developed, this will be the topic now. This theory is developed based on the changes of 5 degenerate d orbitals. We have 5 d orbitals. D orbitals, we have 5 parts here. 1, 2, 3, 4, 5. 5 parts. So based on these degeneracies, the changes of degeneracies, this theory is developed. When the ligands interact, when the ligands and the transition metals interact, the electrons of the ligands surround the d orbitals, due to which sometimes these electrons might be close to some d orbitals and farther to some d orbitals. You can see the distance. If I have 5 d orbitals here, 5 degeneracies d orbitals, and then I have the electrons, non-bonding pair of electrons. Some might be closer to the d orbitals, some might be farther away. Due to this, there is, you can say, a difference of energy levels, and by the difference, the degeneracies get broken down. That is what it's being explained here. Let me just clear the slide for you. Okay, here there is a loss of degeneracy due to the ligand approaching the metal ion. The electrons in the d orbital and those in the ligand repel each other due to the repulsion of like charges. Simply, if I need to conclude it, then I can say there is a breaking of degeneracies due to the formation of bonds. Okay, that is just the summary of crystal field theory. Okay, this is all of the crystal field theory. Now let's get into the hero of our movie, or you can say this video, that is, yes, ligand field theory. Ligand is not a name. Ligands, you know what are ligands? Ligands are ions which are connected to the central atom. Okay, that's it. Simple one. Now let's see the ligand field theory. Ligand field theory or LFT, it describes just the bonding or you can say the orbital arrangement in coordination complexes. Coordination complexes, I have already explained what are they. It represents the application of MO theory and CFT, that is crystal field theory, in transition metal complexes. You have the same bonding, anti-bonding with the explanation how it happens of the crystal field theory. Crystal field theory is the explanation, ligand field theory is the application. So here's the clarity between both of them. In the ligand field theory, a transition metal ion has 9 valence atomic orbitals consisting 5 NDs, 1 n plus 1 s orbital and 3 n plus 1 p orbitals. That's it. So how does the transition metal look like? Like this. These orbitals of appropriate energy form bonding or interact with the ligands. How they interact? Based on the molecular orbital theory. And also, what happens to the degeneracies of these bonded atoms when other ligands come to interact? Based on the crystal field theory, the degeneracies break and the bonding happens. This LFT analysis is dependent on the geometry of that complex, specific complex. If you're studying about a particular compound, it depends on the geometry. The LFT analysis is dependent on the geometry of that. But most explanations, we use the octahedral complex. You are seeing it here, where 6 ligands here, 1 2 3 4, you can see 1 2 3 4 5 6 6 ligands coordinate with this metal complex. Let me just erase all the ink on the slide. You have here 6 ligands with the cubic here cube form of the you can say central atom. Okay, that's it friends. This is not a very large huge theory, it's just a simple theory. Yes, that's it. This is the ligand field theory, the application of bonding in coordination complex or transition metals. This is the application. Crystal field theory is the explanation. That's it. So that is all of the theories of chemical bonding. If you are really interested to learn more, please subscribe the DD Way. Thanks for watching.